is very similar to what we did with just similar polygons in section 7-2, I believe. But we have to make sure that we understand which parts should correspond to one another. And it's kind of messy initially if we don't add some stuff to this picture. First thing I want to talk about is the fact that we should know that angle and that angle there should be congruent, right? Why are they congruent? They're vertical angles, okay? Now, in order to, because you could probably do this and say, oh, I know that 2x, think about it this way, is 2x the segment that is between the two angles that are identified up here? What is the segment that's between the two angles that's identified down here? 16, right? So I can probably say 2x needs to compare to 16. Would that be a fair statement? Yeah. And then obviously then the only thing that's left over is 8 and x, so you compare those, right? Yeah. That is okay. That's not bad to do it that way. But that could get you in trouble, especially if the pictures are orientated maybe a different way. Maybe you have more segment length, so maybe if they give you this segment length here and the one over here, what parts do I compare? Okay, so here is my suggestion to you. When they don't put labels in, put them in yourselves. You can name these anything you want to, but call that A, maybe that's C, or B, C, D, and E. And like I said, you can name anything you want to, but the reason I do that is because now I can talk about the triangle on the left as being triangle ABC. Similar to, now triangle, if that was A and I went to B, I start at E and go where? D, and then finish at C. So those two triangles are similar by the angle-angle postulate, right? Okay. But the direct conclusion from that is that AB compares to ED, BC compares to DC, and AC compares to EC. And now I go through my picture and say, okay, what components of this extended ratio or extended proportion can I plug in? Well, I know AC is 2x. So I'll take this AC right here, put a 2x. I know CE is 16. So put 16. So automatically compared the right things for me. Does that make sense? All right, and then I go find what BC is 8. Let's put 8 there for BC. And DC is X. This ratio is non-existent, doesn't work, doesn't do anything for us because we don't know those values. But now, if I'm looking at this proportion, what can I do? Cross multiply, can't I? So I get 2x squared is equal to, well, let's do it this way first. Does it make more sense to do it this way? Or is there a factor of 2 in both those? So now x times x is x squared. 8 times 8 is 64. So what is x then? Careful. Positive and negative 8. And that's just something you got to pay attention to now because of how the information is provided in the problem. Okay? There are 2 answers here. But remember, when I plug those answers back in, those x values represented what things? Side lengths, right? Represented distances. So can x be negative 8? No. Okay? So that's the reason why we kick that negative 8 out. But what I want you to understand is when you take a square root, you do get 2 answers. And there will be the rare occasion that you want to keep the negative one because of just how the expressions in the problem, the context of the problem, were developed or related to one another, so the negative one does end up working sometimes. Does that make sense, everyone? Yeah. So don't just arbitrarily kick it out because, well, we never use the negative one. There may be situations where we could use the negative one. Okay? For instance, if I would have gotten, maybe they start the problem off with this being negative 2x and this being negative x. Now when I cross multiply, I would have 8 over negative x is equal to negative 2x over 16. Well, the 2's still cancel, leaving me 8 there. Now I would get negative x times negative x gives me x squared again, right? Equals 64. X is equal to positive and negative 8. But can now, if I plug it back in now, can it be positive 8? Can it? If I plug positive 8 in here, it would give me negative 8 there, right? Can it be negative 8 though?
Yeah.
Yeah, because now it's the opposite of negative 8, which in the opposite of a negative is a positive, right? So that's a situation that maybe just the way these were presented to you at the beginning, the negative value is the one that works. So don't arbitrarily, just because it's negative, the x value is negative, kick it out. All right? You got to go back to the picture and check. Is that all right? So I know 17. Let's look at 18. All right, kind of a similar thing. Different reasoning for saying that these two shapes are similar. We know that this angle here is in both triangles, right? Okay. Let me look at the similar triangles. For the pair of similar triangles shown to the right, find the value of x. All right, so they're telling me these are similar. I don't know if this is a great question for maybe making the argument of why they're similar, but if they are similar, that angle there has to be in both triangles. And what we would find out is that angle there and that angle there would be corresponding, wouldn't they? Okay, so kind of redraw on this picture. Maybe I get A, B, D, and then the bigger triangle, A, C, E. But we know A is congruent, congruent in both, and then we're saying that B and C are congruent, or D and E are congruent as well. But this allows me to say that A to B is 13, right? What is A to C? X plus 13. Can I write that as 13 plus X? Yep. B to D is X plus 2, and C to E is X plus 17, right? So now in making a similarity statement, I'm going to say triangle ABD is similar to, so A to B to D needs to be ACE. So now the argument is AB compared to AC, BD compared to CE, and AD compared to AE. Okay. I think at some stage, some of you are going to say, I don't need to write this down because I know 13 is going to go to X plus 13. I know X plus 2 is going to go to X plus 17, right? Some of you can do that. That's fine. But in the event that you get stuck or your pictures is not as easy to make that comparison because of their orientation to one another, that will always get you the right arrangement. Okay, so AB is 13, AC, X plus 13. All right, BD, X plus 2, and CE, X plus 17. All right, so now you might see the reason why we spent time on factoring, because now when I cross multiply, what's X times X? X squared. I'll get 13X and then a 2X. Add those together, I get 15X, right? 13 times 2 is 26. Now I get X times 13, so that's 13X. And now 17 times 13. What I'm going to do what's 10 times 17? 170. What's 3 times 17? 51. So that gives me, what, 221 when I multiply those together? Okay. So now, just kind of working there, we're going to get X squared. I'm going to subtract 13X from both sides, so plus 2X. And now remove 221. 26 minus 221. Is that 195? Okay. Now, here's the kind of the trick that I'm going to use with you. And you can use this if you want to. You don't have to. when we look at factoring this thing, we want two numbers that multiply together to give me negative 195, but add up to give me a positive 2. So the negative 195 tells me that the numbers have to be, one has to be positive, one has to be negative, right? Multiply together to give you a negative. Because if they're both positive, that product will be positive, right? If they're both negative, that product will be positive. So one's positive, one's negative. But that positive 2 that they have to add up to tells me that the numbers I'm looking for are really, really close together. Okay? So they're like maybe like 15 and 17, or they're 13 and 11, or something like that. Does that make sense? Those numbers as groups are really close together. How do I find those real easily? Well, the idea is if they gave me 0, if they add up to give me 0, then they would be complete opposites of one another, right? Okay. And the way we would end up doing that and figuring that out is to take that number 195 and take the square root of it, and then one would be positive, one would be negative. But they differ a little bit. Okay, but I'm still going to do the exact same procedure. I'm going to take 195, and I'm going to take the square root of it. Okay, so however you do that on your calculator, it's up to you. I use, and you'll understand maybe when you get to Algebra 2 why I can do it this way, but raising something to the half power is the exact same thing as taking the square root. Okay, if you want to hit the square root button and type in 195, that's fine. But what this tells me is that my two numbers that I'm going to multiply together have to both be around 13. Okay, so I'm going to take 195 now, 195, and divide it by whole numbers that are close to 13. So it's probably a good idea to start at 13. Whoa, might want to hit the divide button. And this one just works out that there it is. Okay. Sometimes it'll work out where it gives you a decimal, and then you got to try 14 until it starts giving you a non-decimal value that gives you a whole number back, or an integer back. Does that make sense? Okay. So now I've got my two numbers, 13 and 15. Which one of those has to be negative to add to a positive 2? 13. So x minus 13, x plus 15 equals 0. X equals 13. X equals negative 15. Now, go back up to my picture. Can x be 13? Is 13 plus 2, is that okay? Gives me 15. 13 to be okay here. 30 to be okay there, right? Let's try negative 15. Can I put negative 15 in here? Careful. Can I put it in here? Yes. But can I put it in these two spots? No. And that's what I kind of try to draw your attention to that first, because with some values, you may get a yes statement. I can plug negative 15 in x for x plus 17 and get a positive distance. But you need to realize that it needs to be plugged in everywhere you see an x and have that conclusion everywhere you see an x. So in that case, there are two places that it fails. Okay, and failing one time is enough to say it fails always. Okay, or just in general, it cannot be a solution. So the only solution there, 13. Okay, you guys remember what the word is for something that is an extra solution? It has the root extra in it. The root word extra. Extraneous. Okay, that is an extraneous solution. And it all comes from the fact that factoring occurred here. A lot of times when we do some factoring and foiling, that process can create extraneous solutions for us, things that don't necessarily work. Does that help a little bit with those questions? Mm-hmm. Okay. Okay. So let's. Do you want to use your numbers? Do you have your numbers still from the picture? Or?
Yeah. 2x minus 4, and then 42, and 24, and x plus 8.
Okay. So. And this question was on the quiz, which I put it on there just to see what we know. I'm actually going to go back and make that kind of a bonus question. So if you got it wrong, it doesn't really affect you, but if you got it right, great. You get those additional points off top of that. But you said you had 2x minus 4 here, right?
Yeah.
And this was x plus 8?
Yeah.
All right, so we don't really have enough information here to make the argument that these two things are similar by angle or side or something like that. But what we do have is the fact that they tell us they're similar. Okay, so that's nice. But we have only 4 of the 6 sides, right? So and one of the sides is the hypotenuse, right? If they were to put the 42 and the 24, or sorry, the 42 and the x plus 8, like here, I put the x plus 8 there and the 42 here, we can't answer this question because I don't know if I put them there, I don't know if the 42 compares to the 24 or if the 42 compares to the x plus 8. Does that make sense? I don't know which sides are longer and shorter. But if they're giving me both hypotenuses, I do know that a hypotenuse has to match to a hypotenuse, right? Does that make sense? Because they are both the longest sides in their respective triangles. And that's how similarity has to work, okay? So I know 42 should relate to x plus 8. So 42 compares to x plus 8. All right, so what should I then put in this position here? 2x minus 4. Okay, because that's the leg of that triangle. Okay, so I want my numerators to come from the same shape. And then down here should be 24, right? Okay. Now, you could go and start multiplying right now. But I maybe would recognize, or hopefully try to recognize, can you factor a 2 out of this? Okay, so when you factor a 2 out of that, it's going to look like 2 times x minus 2, right? Can you factor a 2 out of the bottom? So it's going to look like 2 times 12, right? What happens with those 2's? They can cancel. So I'm actually going to rewrite this thing here as x minus 2 over 12. The benefit of doing that is now when I cross multiply, it's a 1x squared. Okay, not a 2x squared. Is that all right? No, because this is 2 times 12. I'm sorry. So that's x squared. I'll have x times negative 2, so that's negative 2x. And then 8 times x, so total of what? 6x minus 16. Now I'm going to multiply these two things together. So what's 42 times 10? 420, right? What's 2 times 42? 84. What's 420 plus 84? 504, right? Now I'm going to subtract the 504 from both sides. So you get x squared plus 6x minus 520 is equal to 0. Is that all right? Okay. Now I'm going to do the same thing that I did, because 520, there's a lot of factors to 520, right? Okay. It's a pretty large composite value. Ends with a 0, so we got all those 2's and 5's and 4's that probably all divide into that. So my suggestion, take your 520. One factor's got to be positive, one's got to be negative. And this 6 is relatively a small number, right? Okay. Now, even if that was like a 30, I would say that 30 is relatively a small number in comparison to 520, right? But I know that my two numbers are going to differ by 6 units. So I'm going to take 520. I'm going to take the square root of that. So it gives me that number right there. And now all I'm going to do is I'm going to take 520 and start dividing it by numbers that are close to 22, integers that are close to 22. Okay? And determine which one of those is going to give me back a whole number. Okay? So 520 divided by 22, and there's other ways of doing this, not a whole number. 520. So now I'm going to go, I either go up or down. It doesn't matter. Okay? So either go up to 23 or down to 21. If I go to 23, doesn't work. 520 divided by 24, doesn't work. 520 divided by 25, doesn't work, but you start to see it. It's pretty close, right? It's almost a whole number. 520 divided by 26, and there's my 20, right? Now, hopefully, maybe you saw that 52 Okay, you know 52 is 26 times 2, right? That kind of makes sense? So maybe that would help you get the 26 and the 20. But those two values are your factors.
So, when I was doing something about 2x squared and then the rest of it, so everything you took 2 out and divided everything else by 2?
Yes, and I'll talk about that here in a moment.
I mean, I have to write
Yeah. Yep. So I'm going to write this as x. Now, what, minus 20, x plus 26 is equal to 0. So it gives me x is equal to 20, and x is equal to negative 26. Now, can x be negative 26? No, and that's why the directions, if you read them, say write your answers with commas if necessary or if needed. Not needed here. I don't have 2 answers, right? So 20 is my only option. Now, I think that's the most efficient, that's the best way to approach it, okay? Let's go back through, see if we reproduce the same exact answers using a different approach, and maybe not using all the simplification that I went through. So if I go, we have 42 over x plus 8 is equal to 2x minus 4 over 24. Okay, so cross multiply. Doing my means, x times 2x is 2x squared, right? X times negative 4 is negative 4x. 8 times 2x is 16x. 8 times negative 4 is negative 32. And now 42 times 24 1,008. Is that right? So just like before, still got to get everything equal to 0. So I have 2x squared, plus 12x. Now I'm going to move out or move over that 1,008. So this becomes negative 1,044. Is that right? 40. All right. So now, okay, Mariah, you're saying you divided a 2 out of everything, right?
Yeah.
And that's perfectly fine because remember, this is simply, when I know what x is, this is just one number, right? Okay, so you're saying I'm going to factor a 2 out. So it becomes x squared plus 6x minus 520 is equal to 0, right? Now you have 2 times a number, correct? Is equal to 0. Can I divide this side by 2? As long as I divide that side by 2? Here they disappear. What's 0 divided by 2? 0. And that's where we get the x squared plus 6x minus 520 equals 0, right? You might be a person that sees, this right away and doesn't recognize that there's a 2 in there. You can take it out. And you might think A times C method. It might work. I'm not going to go that route. But you might do this as well. You might say x is equal to the opposite of b plus or minus b squared minus 4ac all over 2a. Okay. Now, Vera, did you take the 2 out before you started doing things? Okay, left 2 in. Good. All right, so leaving the 2 in, I'm going to go opposite of b, so negative 12 plus or minus. Okay, now b squared would be 144 minus and 4. A is 2, and C is negative 1040. All over 2A, so that becomes 4. All right, so that's what x is going to equal. This is a really, really ugly way of saying that we have the answer of 20 and negative 26. Okay, so these two numbers, one of these numbers is 20, one of them is negative 26. We just need to evaluate, simplify, reevaluate, and keep doing that process until we get down to one set of concise values. So what we need to do first is this stuff inside here. We call that the discriminant, if you remember from last year. If you guys are using your calculators, it's not a bad idea to use your calculators. Don't type this all in at once. You're going to make mistakes typing it all at once, but you can type in your discriminant all at once, just the way you see it, because our calculator knows the order of operations. So our calculator knows that you really should multiply these three numbers together. And I'm actually going to multiply probably these two numbers together first. Get the negative 2,080. Multiply that by negative 4, so now it becomes a positive number. And then you add that to 144. So it knows to go through that order of operations to get that number. So right now we have 84, 64 underneath here, all divided by 4. Okay. Now that 84, 64, what you always want to do is see initially, is it a perfect square? And it tells us in this case that it is a perfect square, right? We'll work in some situations where it's not, and we'll talk about what we need to do when it's not. But that gives me now negative 12 plus or minus 92 all over 4, which then that creates the two values of x. X is equal to negative 12 plus 92 over 4, or negative 12 minus 92 over 4. Negative 12 plus 92 is 80. 80 divided by 4 is 20. Negative 12 minus negative 92 is, 104? Negative 104 divided by 4 gives me negative 26. And then those are my two values of x. Those are two values we found factoring the other way. And obviously we only want to keep the x being 20 because negative 26 will be a problem there. Do you see where you made your mistake?
Yeah.
Cool.